So now what we want to do is we want to find where the focus points are. So how do we find where the focus points are?
Square root of 81.
Where do the focus points in general always sit on all these graphs? Inside the branches, huh? Same thing here, no new story. Right there, it's going to be a focus point. Right there is going to be the other focus point. Yeah, they're up, down, huh? Because again, it's all about if you have Y in the front, the branches go up, down instead of right, left, and the focus points are up, down. Now, we need a focus equation to find the focus points. So what do you think? Remember the other focus equation for the ellipse?
A squared minus B squared equals C squared.
Yeah, it was A squared minus B squared equals C squared. This one, the sign in the middle has switched, and the sign in the middle will switch here too.
So now
It's the actual Pythagorean. Yeah, do you see that? So the way I'm trying to help you memorize the whole thing. So basically for the ellipse, the original sign is positive and the focus one is negative. For the hyperbola, the original is negative and the focus is positive. So the focus is always the opposite of whatever sign is in the original. All right, so now we just do the same old thing we always do. What's A and B? Which one, by the way, which one's A and which one's B? Who cares? For the hyperbola, we don't care. Why? Because they're added. We don't care. That's what's nice. Hyperbola is a little bit easy. Remember how we were always uptight about that for the ellipse? Where it's like, oh, the bigger one's got to go first. Because when you subtract two things, we remember because we had minus here for the ellipse, right? And when you subtract, you got to put the bigger one first. And we were always uptight about which one was bigger and smaller and all that. For this, we don't care. They're added. So never worry. Never worry about which one's A and B. Doesn't matter at all for the hyperbola. So just 9 squared plus 8 squared, or the other way, whatever, same thing. And what's the C? I don't know. That's what I'm going to try to find here. So that's going to be 81, 64. What's that, some big number? 145. 145, Abdul says. 145. 145 C squared.
No, it's
Last step to get C alone.
in the orange.
Root it. Now, if you check root of 145, you'll find there's no breaking it down. If you divide, clearly 5 goes in, huh? Because this is with a 5. You'll find it's 5 times 29. 29 can't break down, so there's no simplifying that. So it just stays root 145. Now, it's plus or minus.
Yeah.
So this point is over 0 up root 145. This point is over 0 down root 145. We got our 2 focus points.
Oh, okay.
That good?
For some reason, the focus points are really hard.
So up and down root 145. That's a number more than 10, right? Because square root of 100 would be 10. That's more than 10. So it's beyond the 9, isn't it? You with me? I don't know what it is. You do the calculator, some decimal thing. It's more than 12 even. Yeah, it's just over 12. About 12.01 or something. Because root of 144 would be 12. So it's just over 12. So anyway, whatever. It's past 9. I'm just saying, hey, it's beyond 9. It's below negative 9. It's like negative 12, positive 12, something. So, all right. So we got that. Last thing. There is one more thing they want you to do. And then I'm going to write a summary of all this. They want you to find the equations of those asymptote lines. You see those 2 diagonal lines? We don't care about the box anymore, but just the lines. Yeah, right. Yeah, so it's one line going up and one line going down. So one's going to be a positive slope and one's going to be a negative slope, right? So they want you to find the equations of this line and of that line. So how do we do it? Yeah, it's a line. Remember graphing lines from your algebra days. Well, how would you graph like 2x plus 3?
The y-intercept.
Where do you start?
The y-intercept.
Yeah, this is the y-intercept. It's the b. And that's on the y-axis. Huh? You go up to 3 right there. That's where the line hits the y-axis. Call that the y-intercept. And then from there, where do you go? Yeah, rise over run. Put the 2 over 1. Rise over run, which means you go up 1, 2, over 1. Connect the dots, you got your line. See, it goes through 3 and up 2 over 1. So yeah, exactly. So let's go back then. with that thought in mind, let's look at the asymptote lines we have here. That's just a mess. Let me rewrite that. We need a little more clarity there. So we have these, how far did the box go? Oh, up to 9. That's right. Up to 9, down to -9, over to 8, back to -8. All right, so and then these lines go through that. Now it's important to know how big the box is because that's going to tell us the slope for those lines, you see. So this line goes like that and like that. I'll just do that one first off. So think about the equation of that line. It's mx plus b. What's the b? What's the b? The y-intercept. Where does that line say, hey, red line, where do you hit the y-axis?
0.
Right there at 0. So the b is 0, huh? Right? He hits the y-axis at 0, at a height of 0, doesn't he? Right? Remember, graphing, wherever it hits the y-axis, that's the number that goes out there.
9x plus
So that's 0. Yeah, and then what's the slope? It's rise over run, huh? And this is just 0 back there. Rise over, yeah, what's the rise?
9.
9. Yeah, it's the box. You know, from this dot to that dot, up 9 over 8. Up 9 over 8, yeah. 9 over 8x. And we also, that's the positive one. And then we also have the same thing going down. So basically it's plus or minus 9/8x. That's both equations at once. See how easy that's going to be? Let me make that even easier. Let me bring back the equation. What was the equation? There it is. Yeah, let me write. Remember the equation? It was y squared over 81 minus x squared over, 64 is 1. So all you have to do to make this super easy, remember the y squared is 9 squared, the x squared is 8 squared. You just say, look, hey, whatever's underneath y, that's got to be your rise because that's up, down. That's your rise. And whatever's underneath x, that's your sideways because it's x, sideways. That's your run, 9 over 8, done. And plus or minus because one line goes up, one line goes down. So that's how you find the equations of those two asymptote lines. All right, so that's it. That's that problem. So let's what could we summarize? Maybe best just to try another one here. So for the hyperbola. So let me write out just one thing quick. So for the hyperbola then. So if you have, it's going to be up, down when y squared is in the front. And it's going to be right, left
When x is in front.
when x is in the front. So it's all about who's in the front. It's not about who's bigger. And that's going to need to be an adjustment in your thinking. Because in the ellipse section Tuesday, ellipses were all about which one was the major axis, remember? Which one was bigger. We were all uptight about that and careful about that because that's where everything went. The focus points were there and everything else was there. But now for the hyperbola, we don't care which one of those is bigger. We just care who's in the front. Who's positive, in other words. You see what I mean? See how this fraction in the front is really positive? He has no sign in the front of him. And the one in the back is negative. So really, it's about which fraction's in the front, which fraction's positive. That's where everything goes. So if there's y in the front, it's up, down, and the focus points are up, down, inside. If it's x in the front, it's right, left, and the focus points are right, left, always inside the branches. And the focus equation is the literal Pythag, right? Pythagorean theorem, a squared plus b squared is c squared. And then you know how to do the asymptote, rise over run. So yeah, I'll write it down real quick. Asymptotes, y equals plus or minus rise over run x. And there we go. Is that good? Notice something, yeah.
What's the transverse
Josh.
axis?
Yeah, transverse axis is the axis it's on. That's right. So this one would be y-axis. Transverse, trans means across, right? So transportation takes you across town. Trans means across when it's in front of a word. So the transverse axis is the axis that the lines cross. So that would be the y-axis on this one. So for this one over here, The transverse is the x, because the branches hit the x. On this one, the branches hit the y. So transverse is just, hey, what axis is it on? They'll ask us that. Notice they're going to ask you for the vertex points. Let me try to make a couple of sweeping statements that'll kind of help you keep all these sections together. Let's think about something for a minute. You know, for the parabolas, go back to the parabolas for just a second. Parabolas just have one branch, don't they? Why? Because they only have one letter squared. Remember, parabola, only one side squared, the other side's not? That's why they only have one branch. Next, so think about it this way. Next comes the ellipse. So this was parabola. That was section 10.2. And then next, we have like the ellipses, right? It's an ellipse. Section 10.3. That's because they have both letters squared, don't they? So they have a positive relationship. They're like two branches that come together. They have a positive relationship. And now finally, we have the hyperbola, which is going to have two branches with a negative relationship. Hyperbola 10.4, and so that would be, this one would have x squared in front, wouldn't it? Because it's right, left. Okay, is everybody getting that? So we have these three scenarios. So if you have one letter squared, you have one branch. You have two letters squared, you have two branches. Positive in the middle, positive relationship, they make an ellipse. Negative in the middle, the branches turn away from each other. They have a negative relationship. If x is in the front, it's right, left. If y was in the front, be up, down. Okay, not only that, they're going to ask us for vertex points all the time. Plural is vertices, right? Notice that the vertex points are always the center of the U shape, or the C shape, whatever you want to call it. Not the center of the whole picture, maybe. Did that sentence make any sense? Let me help you unpack that sentence. So notice right here. That's the center of the branch. That's called the what? The vertex. It also happens to be the center of the entire graph. Remember, for a parabola, vertex is center because there's only one branch. So if you're the center of the branch, you're the center of everything. Whereas over here, the vertexes are here and the center of the graph is right there. A little different. These are the vertices. See how the vertices are always in the center of the branch? But if there's two of them, then the graph has a different overall center for both branches. Same thing over here. Here's the center of the overall graph, center of both branches, right? But these points are the vertices. Right there and right there. So is that making sense? See how they're using the words all the same way? So the vertices are always the center of a branch. And if there's only one branch, like for the parabola, that's the center of everything. But if there's two branches, then there's a different center of both branches other than the vertices. Good? All making sense on that? So these are all called conic sections. They're sections of a cone. If you take a three-dimensional cone, there are ways of slicing that cone. You will get these shapes, actually. If you slice parallel, you'll get an ellipse. I don't have a 3D thing with me to demonstrate, but we'll move on. Okay, so let's get, there we go. So basically they want you to graph it, find everything in the world. Find the vertices, center, all that stuff. So let's start right there. So what are you going to do first? We got to make the equation look right before we can do our graphing thing, huh? Yeah, got to make a 1 on the right side, huh? All these have 1 on the right side. So you got to divide through by 9, don't you?
Yes.
So divide through by 9, make there be a 1 on the right side. Exactly.
So can we think of when one of the variables is raised to a power and there's nothing underneath it, can we just think of it as 1 squared?
Yes,
Okay.
exactly.
Yeah,
It's going to be 1
really
squared.
Helped me last night.
Yeah, good.
Exactly. I was getting super confused.
Yeah, if there's nothing underneath, it's 1 squared underneath. Exactly right. Good. Good, Renee. So you weren't too sleepy. You were thinking right.
I got in the zone. It was really weird.
Get in the zone late at night. I don't get in the zone late at night. I'm a morning person as much as I
just-
try to fight it.
I was on the borderline of falling asleep, but I had to finish it because I still have to finish Parabolas.
Yes. All right. So we good to there? So you got to get a 1. We always have to get a 1 on the right side. Now go ahead and make, like Renee was saying, make those squares, right? So this is really 3 squared. And what's under here? 1 squared. Because that doesn't change anything,
Yeah.
right? That's the same. We're always doing plastic surgery, right? Removing the wrinkles without changing the value. Why? Because it's for our convenience. We have to have a number so we know what to do on the graph.
Right.
That's like half of math and science, is make it look different so you can do what you need to do.
Because it's not 0, it's 1.
Yeah, right. X divided by 0 would be undefined.
Mm-hmm.
It wouldn't be X. All right, so put that on the graph now. Are the branches, well, yeah, I'm going too quick. So go ahead and put that on the graph.
So is this going to be like a rectangle instead of a square?
So start with the box. So whatever's underneath X is right, left. So I have a 1 underneath X. So I'm going to go right 1, left 1. We good? And what do we have underneath Y? 3 squared. So I'm going to go up 3. Down 3. And then make your box, your dotted box. It's going to be a tall, thin box. Like that. And then put in the big old X. The whole purpose of the box is to hold the X just right. So you know how steep the X's should be. The asymptote lines. Because those are what actually guide the branches. They tell you how wide to open the branches. Good. All right, so whatever's underneath X, right, left, Y, up, down, make the dotted box, put the X in. Now, are the branches going to be up, down, or right, left?
Right, left.
Yeah, because X is, again, it's not about who's bigger. Because the Y-axis is a bigger number. We don't care about bigger. We care about who's in the front. It's all about who's positive, who's in the front. X is in the front. So the branches are going to go right, left. Now, where do they, if they're going to go right, left, where do they start?
1.
Right here in the middle. Yeah, right at the 1. And it's going to go up and down to the right and the left. And it's going to get closer and closer to those guidelines forever. Those asymptote lines will guide the branches. It tells us, those are wide branches, aren't they? It tells us how wide those branches open. Okay, so now let's go back and see if we can answer a bunch of the questions now. Here's the questions they're going to ask you. First off, what's the center? Yeah, the center is just 0, 0. The center of the overall graph is right here at 0, 0. So that's just 0, 0. Next question. The transverse axis, this is what Josh was mentioning. The transverse axis is along what axis?
X.
Yeah, that just means right, left, X, up, which axis is it hitting? It's hitting the X, isn't it? So that's X-axis. The vertices. Now it wants to know the vertices.
-1, 0, and 1.
Yeah, it's this right here and this. Remember, it's always the middle of the branches for all these different graphs. A vertex point, the vertices, plural, is the middle of the branch, huh? So what's the coordinates on that? 1, 0, and this one's -1, 0. So the way that they want you to say it is it's plus or minus 1, 0. See how they already have the plus or minus in there for you? So nice of them. They're just making this so easy. No, I mean, it's long and tedious. All right, next question. Foci. Where are the focus points? Yeah, so where, in general, they're always inside the branches, aren't they? For all of our shapes. So let me get rid of this stuff. And, yeah, so let's go over here and say, well, there's going to be something there, and there's going to be something about there. Those are going to be my 2 focus points. How do you find them? The focus equation, yeah, which is the Pythagorean, isn't it? So it's going to be a squared plus b squared is c squared. Everybody seeing that? So the sign in the focus equation is the opposite of the sign in the original. That works for both ellipses and parabolas. So if you, ellipses and hyperbolas. If there's negative in the beginning, there'll be positive in the focus. If the original had positive, then the focus would have negative, wouldn't it? All right, what's a squared and b squared? 1 squared and 3 squared. Doesn't matter what order, right? Because they're being added. So that's going to be 1 plus 9 is c squared. 10 is c squared. Root it. It's root of 10. C is the root of 10. Plus or minus. So that means...
So would it be 1 plus root 10? Or would it be from the center of the graph?
Yeah, good question. It's from the center. Really, it's not the 1. Really good questions. Everybody hear that? It's a good question. A, B, and C, remember, are always from the center. So that means from the center, it goes right, root 10. And from the center, it goes left, root 10. Yeah, from the center. Always from the center. Not from a vertex point or from anywhere else.
I kept wanting to do it from the vertex point.
Yeah, always from the center. Everything's A, B, and C are always from the center in all the graphs we've been looking at. Always from the right. A and B are from the center, up and down, right and left to the box. C is from the center to the focus. Always. All right, so then what are the two focus points? This would be root 10, 0. This is minus root 10, 0, isn't it? Right, root 10 up 0. Back, root 10 up 0. We good? So then that goes back here. That's plus or minus. They already have the plus or minus. See how nice they are? Plus, they have the plus or minus root 10, 0. For the two focus points.
The equations of the lines.
Now we need the equations of the asymptote lines. I'll let you do that. Remember, rise over run. Rise over run. Rise over run. So can I bring it down here? I'm going to erase the bottom of this thing. And yeah, asymptote. How we always do it. It's harder to spell the word asymptote than it is to find them. Okay, it's always plus or minus rise over run x, right? Because one line goes up, positive, one line goes down. So what is the rise? Where do you look to find the rise? Under the y. Because y is up, down, huh? That's got to be rise. Where do you look to find the run? Under the x, because x is sideways. So that's just 3, isn't it? So, whoops, going too fast. Plus, come on, pin. Plus or minus 3x. There we go. All right, so that's it. So we go back here. We go, they already got the plus or minus again. 3x. There it is. We answered all their questions. We have the other one is the graph. We have the graph. Questions I can answer on that one? It's very similar to the ellipse, isn't it? So it kind of reinforces what you already learned. It's kind of nice that way. No questions? We good? All right, I'll move. Okay, so here's question number 1. So, yeah. So looking at that thing, it's multiple choice, and I'll show you the options. In fact, I guess I could. There's our 4 options. Let's go back to the graph. Okay, so there's the graph. So let's think about the graph. We'll flash back and forth to the options. So what do you know right away about, as you look at the graph, what do you know about the equation? They want the equation. Yeah, branches are up, down, huh? They're not right, left, they're up, down. So it's got to be y squared in the front, for sure. You know, minus x squared over something equals 1. Good. So we go back to the options. What do we have to have in the front? We got to have y squared in the front, because the branches go up, down. So which ones can we cast out right away?
A and B.
A and
B, C.
A and D are out. A and D are out, because you got to have y squared in the front, huh? Good so far? Now, let's go back. Do we know what's under y squared or what's under? Yeah, you always know one of them. Let me give you this tip. For hyperbolas, you always know one of them right away. The other one, you can't tell. You have to get the focus equation involved. which we're not going to do. You can tell one of them right away because it's the one where the branches sit. So the branches are up, down on this one. So I know what's under Y. I know this one right away. Why? Well, it's how far up this? Where is this?
Just one.
That's up 1. That's up 1. So that's got to be 1 squared, or just 1. Make sense? Wherever the branches are, you know the number under that letter. If branches are up, down, you know the number under Y. So let's go back. It's got to be the one that has 1 under Y. See, it is. Good? Easy enough. Okay. So it's giving you, basically it wants the equation. So take that information now and begin to draw a graph. Just, just make an axis system. Put those are 3 dots. Center dot, focus dot, vertex dot. Put them on a graph and, just begin to try to draw a little bit of the graph. Just enough to where you can tell what the equation is. The whole point of this question is find the equation in the end. So let's draw a graph. Center is 0, 0. Focus is 10, 0, right? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 0. Oops.
So,
Vertex is 6, 0.
whatever A and B is, the square root of those two added has to be 10.
Yeah, we'll get there. Okay, so everybody good so far? We got the center and the vertex and the focus. Okay, so remember we're trying to come up with the equation. So can we put a branch anywhere?
Yeah.
What do the branches always hit? They always physically make contact with what? Center, vertex, or focus?
The roots.
Vertex. They always hit the vertex. Remember back here? Remember when I was giving you the big picture? Where was it? Uh-oh. That is not what I wanted to do. Here we go. Where was it? Here. Remember I was showing you how the vertex points for all these graphs always hit the center of the branch? For all the graphs. See how the vertex is here? Here. Here. It's all here. Here. It's always the center of the branch. That's what a vertex is. Center of a branch. So getting back to it. So the branch has to be right going like this, doesn't it? Right? Because the vertex has to hit the branch, has to be the middle of the branch, and the focus has to be inside. So remember, the focus point is always inside, and the vertex is the center of a branch. And then there would be another branch over here. I don't really care a lot about the other one. There'd be 2, though, of course. And they'd be right, left. So what does that mean, then, about the equation? Why am I doing that? Because I'm trying to find the equation. So what do I know about the equation now? What goes in the front? Who comes first, x squared or y squared? X squared has to come first because the branches are right, left. Yeah, good. Minus y squared equals 1. Okay. So we know the branches are right, left. Now, the way this is going to work, here's the game they're going to play. They're going to play this game with you. And that is, you're always going to get one of the numbers, either the one under x or the one under y. And what it'll be is the one in the front. Yeah, I'm learning the game with you here. You're always going to have the one in the front. So you can always find the one in the front because those branches are sitting on the graph. The second one, you'll have to find from the focus equation. But the first one, you get right off the graph. So what's the number under x?
6.
6. 6, yeah. Because 6 squared. Because it's how far from the center. Remember, the A and the B are how far from the center to the edges, and C is how far to the focus. So that's 6. I don't know what's under y. This is what's always going to happen. You'll always know the first one because it'll be sitting right on the graph. The second one you don't know. You find it by the focus equation. So let's write the focus equation. So the focus equation is the Pythagorean, huh? A squared plus B, right? Because whatever sign you have in the main equation minus, it's opposite in the focus. Plus, all right, what's A squared and B squared? That's my 6 squared, and B squared I don't know. What's my C squared?
10.
Yeah, C is how far to the focus. Yeah, just like it was for the ellipse. Same thing for the ellipse. Everybody catching on to what A, B, and C are? A and B are how far from the center to the edges. C is how far from the center to the focus. Every time. So that's 10 squared. So that's what? 36 plus B squared is 100. Subtract 36. Bring it over here. B squared is, what's that? 64. Root it. B is 8. We're done. Put an 8 in there. We got the equation. That's how it'll always work. You will, what goes underneath the first letter will be right on the graph. The second letter you won't know. You got to find it with focus equation. So there we go. The only other thing I think they're going to ask, they ask the transverse axis, don't they? Yeah. They say, what is the axis? What axis is this thing on? X-axis, right? It's hitting the x-axis. It's right and left. Hits the x-axis, and then they just want the equation, which we just got right here. We're done. That's all they want. Good? You think I can clarify on that?
If we were doing the equations of the lines, it would be 8/6 reduced.
Yeah, 8/6 reduced, right. Which would be 4/3. Exactly. Good. Yeah, they don't want it though. They want the equation. Right? Is that what they want? Yep. They want the equation and the graph. Now, like I said, this one's super tricky. Consider it like a challenge problem. Nobody's got it. You guys are the third class this semester. I can't remember anybody ever getting this one. This one's tricky. See what you can do. So put those on the graph. Start by putting those on the graph.
That's the equation of the line, right?
That is.
Negative 1 over x.
So put those two foci points on the graph. See what you can do. A little bit. So over 0, up 6. 1, 2, 3, 4, 5, 6. And over 0, down 6. 1, 2, 3, 4, 5, 6. Right? So over 0, up 6. Over 0, down 6. Good so far. Those are focus points, aren't they? Foci. So what does that tell us? It's kind of weird, starting with foci, huh?
That tells us the square root of A plus B is 6.
Okay, first off, where are the vertices? Well, foci, focus points always sit, notice, let's go back. Focus points always sit inside the branch, don't they? Focus points are always inside, like with satellite dish, all that. Focus points are always inside the branch.
What does he want?
So the equation. They want the equation. Come on, Abdul. I'm counting on you, man. Come through with some trickery here. All right. So first off, the branch is going to be somewhere like this. I don't know exactly where, but I just want to get something to look at. You with me? It's got to generally be something like that. I don't know exactly where those hit, but sort of like that, right? Where it's got to be up, down. And the focus points have to be inside. So good enough? That just gets me rolling on the equation. So if I know that, what do I know about the equation? What comes first, x squared or y squared?
Y squared.
Y squared this time, huh? Minus x squared equals 1.
Yep, so I keep putting plus because...
Yeah, no more plus. That was ellipse. Let me write it again over here. Leave a little more room. Y squared minus x squared equals 1. Good, okay. Now, here comes the trickery. What in the world do we do now? I mean, I don't know. I just guessed where this branch is. I don't really know. I don't know. So I don't know what's under X. I don't know what's under Y.
You have to find A and B, but they'd be the same because the asymptote line is 1. So it'd be A over B. The only way for that to equal 1 is if they're equal to each other. So
Good
A
job.
equals B.
Josh is having some good thoughts. Yes. Yeah, okay. So we're talking, they give me the focus. How about I start you here and then we'll get to exactly what Josh is saying. They gave me focus points. So whenever they give me focus points, I know I'm going to use the focus equation, right? So let me write it down first off, and then we'll think about what Josh is saying. So, right, we're going to have to use the focus equation because they gave me focus points, clearly. Yeah, and now look what Josh is saying about the asymptote line here. He's saying, okay, A and B have to be the same. That's true. What about that negative? Right. Remember what an asymptote line equation equals? It equals rise over run x, doesn't it? Rise over run x. In fact, there's not room for everything here. Let me move it over here. So asymptote equations, always it's y equals rise over run x. Okay, so what? Well, so do I know the rise and the run?
Yes.
What is it?
Well, negative 1 over 1.
Yeah, so should it be negative 1 over 1? Because it's negative, because this is negative 1 here, huh?
Down 1.
Yeah, so should it be negative 1 over 1? But what about what Josh was saying about them being the same?
Was because when we did the asymptotes earlier, we put A over B times X. And so the rise is A and the run is B.
Mm-hmm.
And so if it equals 1, so A equals B.
Yeah, good. What about the negative?
So it's gonna be because as a
It doesn't matter because that one's negative and that one's positive.
Excellent, excellent. Yeah, forget about the negative. Remember, they're trying to trick you with that. Remember the asymptote. Where is it? I gotta go back and find one of them. Let me remind you. Let me go back and find one. Where is one of them? Yeah, remember? They always have both signs. Who cares? There's one going up, one going down. They're just trying to trick you by putting that little negative in there and going, is that going to bug you? There's one going up, one going down. Who cares about the signs? There's always both signs in front, right? So don't let that bug you at all. Just come on back. Yeah, who cares about that negative? Whatever. One's positive. Put both signs there. One's positive, one's negative. Yeah. Now, so Josh is totally right. Now, what about the fact that, okay, so who cares about the signs? It's plus or minus. But what about, isn't it 1 over 1? Doesn't it have to be 1? Aren't these both 1, though? Josh is saying no, because what else could it be? How else can you get 1 other than 1 over 1?
Divide by the same.
2 over 2, 3 over 3, 4 over 4. So it's like Josh is saying. They don't have to be 1 and 1. They just have to be the same.
It's probably 6 and 6.
Right?
No, wait, no.
Does that make sense? So Josh is totally right. These guys just need to be the same. Why don't I call them A and A?
Okay.
Or Joe and Joe? Whatever. You call them whatever you want, but call them by the same name because they have to be the same. Like Josh is saying. That's exactly right. That's how you get 1. You divide the same thing by itself, huh? So this is plus or minus. So what's my point in all that? Well, let's go back over here. Let's try to work with the focus equation. Do I know A, B, or C right now? Do I know C? What's C in the focus equation? 6, right? Because that's how far from the center to the focus point, right? That's 6. But A and B, if I don't know A and B, I can't solve because there's 2 letters here. I can't solve this, but now's where Josh's observation helps us immensely. They're both A, or both B, or both Joe, or both X, or whatever you want to call them. They are the same. See, if we didn't know that, we couldn't solve this thing. You see, that's what the asymptote line information tells us. These guys are not different. They are the same. Because, everybody see why here? The rise and run. The A and the B are the rise and the run, remember? Is everybody tracking with Josh's thought here? The A and the B are what's under X and Y. This is A squared and B squared. And they have to be the same. Why? Because the slope is 1. The rise over run is coming out 1. That means A and B are the same. So call them both A, or call them both B, or whatever you want. This is 36. And now we can solve for A, because now we just have 1 letter. That allows us to solve for A. Yeah, good. A squared plus A squared? 2A squared. Remember like terms? 1A squared, 1A squared. 2A squared. Now what do we do? And divide by the 2. 18. Root it. What's the square root of 18? 3 root 2, because it's 9 times 2, root of 9 is 3.
They just want the answer is 18.
Yeah, I know. Yeah. I'll do that too, yeah. Good observation, Josh. I'm impressed. Good observation. So let's take these back. 3 root 2, so that's our A. So both of these, remember, are the same. So they're both 3 root 2. I'll fix it in a minute. 3 root 2 squared. But yeah, like Josh is saying, they don't want me to leave it that way. But let me slow down for a minute. Are you tracking with me? Mm-hmm. See what's happening. See how this worked. I used the focus equation. I knew the C was 6, because that's how far to the focus. But I didn't know A and B, and I couldn't solve. And then I realized from the if the slope is 1, rise over run, they're the same. The only way the fraction comes out 1 is if they're the same. So they're both A, or both B, or whatever. They're both the same. Then I could solve. They're both 3 root 2.
So is this a hyperbola of a circle?
Yeah, it's, well, the box would be a square, wouldn't it? So the asymptotes would be, yeah, perfectly diagonal. So anyway, if you square this, yeah, they don't want you to write 3 root 2 there like Josh is saying. They want you to square the 3, 9, and square the root, 2, 18. This one's 8. So they want you to write 18. They don't want to leave a root down there. I don't know why, but it bugs them.
They
So
don't let us do it for any of them.
yeah, so they don't want you to leave a root down there. So just square the 3 is 9. See what I did there? I squared the 3 is 9. Squared the root, it removed the root, huh? To be plane 2, and then 9 times plane 2 is 18. And we're done. Is that good? Now you can handle that trick?
Yep.
Good job. Good job, Josh. All right. Let's move on. Is it okay? I flashed off that? Well, here's number 11. All right, so equation. They want the equation. All these, they want the equation. They're giving you the entire box. When they give you the whole box like that,
It's pretty awesome.
you got the equation. It's just being handed to you on a silver platter, basically. So let me show you. Let's do it. So if I'm going to write the equation, first off, what's in the front? X squared or y squared?
Y
Y squared.
It's up, down, y squared. So it's going to be y squared in the front, x squared in the back. Okay? Now, okay, so what goes under the y? We always know the thing that goes under y, because that's from the center up. And how far up is that?
12.
Yeah, you got to count them off, huh? So can you tell that the marks, what do the marks go by?
A's. 2's.
Yeah, it's 2's. Do you see it? Let's count them. So this would be 2, 4, 6, 8, 10, 12. Let's keep going to make sure it's right. 14, 16, and then halfway above that is 17. So yeah, they're going by 2's, aren't they?
Y is 3 squared. Oh,
So this is 12. So that's up, down. So that's under y, 12 squared. And then what goes underneath x? Yeah. 2. They're going by 2's also. 4, 6. Boom. They're giving you the box. They're giving you everything. Problem over. Isn't that great?
Yeah. Awesome.
So if they give you the box, they're giving you what goes underneath x and y. That's very nice. You want a lot of those on the exam, right?
Yes.
Give us those boxes.
Yes.
Box them up, Mr.
Whole
Herring.
thing. The whole thing that.
Yeah, there it is.
I would-
All right, we good there? Oh, they will also ask you for the they always ask you for the transverse axis. Yeah, what axis is this thing on? The y, it's up, down. Yeah, I think that's all they asked for. So there we go. So it wants the equation for that one. So see if you can find the equation.
I wish they had paper with not graphing paper, but with tiny little graphs on it. With tick lines.
They do. I'm sure they do. All right, so start drawing the graph. All right, let's try that. So, oops, make that a little straighter. So over 5, down 1 is the center. And then the focus goes all the way to 10. 6, 7, 8, 9, 10, down 1. And the vertex is at 8. So center vertex. Focus, okay. All right, so can you begin to draw the graph? So start to draw the graph, which means, remember, the branch always physically hits the vertex, doesn't it? It physically hits the vertex. And the focus is always inside the branch. So draw that. So it's going to be right here, just like we did a minute ago. Huh? There's going to be another branch somewhere over here. All right, so that'll help us write the equation. Start writing the equation now. So what's going to go in the front in the equation?
X.
It's right and left. X squared. So it's going to be x squared over something minus y squared over something equals 1. Oh, actually, no. Well, I mean, yeah, that's so far so good. But then the center. You got to do something about the center. You got to move the center. Remember how we did that for the ellipses?
Oh, so the vertex is going to be like the, so like x minus...
No, these are the actual coordinate points.
Yeah, so remember for the ellipse, so if the center was the origin, then we just leave x squared, plain x squared, y squared. So what do we do when the center is not the origin? Remember what we did for the ellipse?
minus 5 squared.
Opposite, opposite. Yeah, for the x and the y. Remember, that's for all the graphs. That's for the parabolas back in 10.2, the ellipses last time in 10.3, and now same thing here. So it's good to see it one more time. From when the center is not the origin, when the center has been moved, then you've got to put into the equation opposite, opposite. So I'm going to come in here. It's not going to be x squared. It's going to be the opposite. It's going to be x minus 5 squared. And because that's the opposite of positive 5, huh? And for the y center is negative 1. So the opposite of that is y plus 1 squared. Good? Remember that? So that's for all the graphs. When the center is not the origin, then you've got to put that into the equation opposite, opposite. Okay, now, do we know the number? We always know the number under the first fraction, huh? We can always get the number right here, under the first fraction.
3.
8.
Yeah, I got 3.
It's, remember what it is? It's how far from the center.
Right.
So from the center to the edge. From
Just 3.
5 to 8 is 3 squared. Is everybody seeing that? So what goes under x and under y is how far from the center, right and left or up and down. So you always get the first one because it goes to the branches. Now how do we get the other one? Always?
Count.
You can
I mean the one that goes under y. How are we going to get the one that goes under y?
I'm gonna have to do the,
Yeah.
We're going to call it b squared and do the focus equation. Yeah, can you do the focus equation real quick? So remember, when you do the focus equation, those are from the center. All those are from the center. A, B, and C are from the center. So I'll use the focus equation, which is the Pythagorean, exactly. Because the original equation has minus, so the focus has opposite plus. So what's a squared and b squared? That's 3 squared b squared. What is c?
5 squared.
Yeah, c is, remember what a, b, and c are. They're from the center to the edges or to the focus. So from 5 to 10. From 5 to 10, from the center to focus is a distance of 5. A, B, and C are distances, aren't they? From the center to the edge or to the focus. Distances. Okay, so there's our equation. You've probably seen that one before. 3 squared plus 4 squared is 5 squared, huh? But if you don't notice it, no problem. Just solve it like regular. 25, subtract 9. So b squared is 16. And we root it and root it. B is 4. So we come up here and put a 4 in, and we are done. We found the equation. Questions on that one?
If we were having to do the equation of the line, it would be 4/3.
Of the asymptote line?
Yeah.
Yes, it would, but it would be shifted,
Yeah.
just like the center. I'll get to one of those in a minute. Basically, you would use this and this instead of plane X and plane Y. I'll just show you real quick. You'd write Y plus 1, equals, plus or minus, and this is going to be, what is it, X minus 5. And then the plus or minus would be rise over run, 4/3. That would be the equation. Because they've been moved just like the whole graph has been moved. Their center's been moved just like the entire graph has been moved. And so this moves them the same way it moved the entire graph.
So you wouldn't want to just get Y alone?
No, they want it just like that. Or they might want Y alone. They're not asking for any of that on this one, so I'm going to move. Okay, there you go. Try that one. So put them on a graph. They want the equation. Same thing again. They want the equation. So put those on a graph.
They have 7 now.
There's a lot of 7s up there. All right, how y'all doing? You getting the graph? Let me go with you there. So focus 7, 2. 6, 7, 2. And then 7, 8. 3, 4, 6, 7, 8. That's way up there. And 7, 7. So here's the focus.
No, it's the other vertex. 7, 3. You find the center by doing x1 plus x2 over 2.
Okay, we good there? That making sense?
7, 5.
So which way do the branches go?
Up, down.
They got to go up, down, don't they? Because what does the branch always hit? The vertex, huh? It always hits the vertex. So it's going to physically hit this vertex, and the focus point is always, there'd be another one down here as well, wherever. So the branches are up, down, aren't they? Up, down, because the branches always hit the vertex physically with a focus point inside. So there's the branches, up, down, like that. Now can you write the equation? Yeah. Yeah. So that focus is inside the branch?
Yeah, but there's 7 Q's of foci.
Oh, I'm being totally crazy. I just assumed that was the center.
No.
Oh, those are foci.
Yeah, the center is
Thank you.
pink center.
I'm being completely crazy. Thank you. That is not right. Let's try again. Yeah. Okay, so this is, the foci are, what were they, 7, 2, and 7, 8?
Yeah.
Yeah, that's not the center. So 7, 2, 7, 8, and here's a vertex. So this is 7, 8, 7, 2. They're both foci, and this is a vertex at 7, 7. Okay, good. Those are foci. So the branch stuff was still true, huh? That's still going to go like that.
Right.
And there's going to be another one somewhere around here, huh? It goes like that. Yeah, the foci are inside. Now we have to find the center. That's right. That's why I wanted to show you this one, because it was a center finder. I want to do one of those again. Make sure you're okay. Can you find the center? What's it got to be the middle of? The middle of the two foci points, right? We don't have two vertex points, or I would just do that. But what I do have is two foci points, two focus points, right?
So you can assume the other vertex.
So the middle, the center of the graph has got to be the middle of those two focus points. So one of them is at 8, one of them is at 2. So one of the focus points is at 8, one of them is at 2. We've got to find the middle of those two. How do you find the middle of two numbers? Average. Yeah, we've done this a couple times, huh? Remember, to find the middle of two numbers, you do the average. So the middle, let me move it over here. The middle of 2 and 8. Middle of 2 and 8, you add them and divide by 2. 10 over 2, 5. 5 is the middle of 2 and 8. So 5, right there. That's the center. So the center right here is got to be over, we knew it was over 7, huh? But it's up 5. Over 7, up 5. So that's the center. So that's the middle of that whole system. Now, you can write the equation, because we needed the center to write the equation, huh? Can you write the equation now? Take it from there. All right, so what goes in the front? X squared or y squared?
Y.
Up and down, y squared minus x squared. And now do I just leave it plain y squared and x squared?
That's y minus 5.
Yeah, remember when the center's not the origin, you got to shift it, huh? Opposite of the center. Here's the center, 7. That's why we had to spend all that time finding the center, because that's going to play a role in the equation, isn't it? Opposite of 7, 5. So careful now, the 7 is the x, so that means minus 7 in the x. The y is the 5. Y minus 5 in the y zone. Is that good so far? So I got the opposite of y next to y, the opposite of x next to x. Okay, now, remember how this works. It's going to work the same way. We can always find the first number directly from the graph. Directly from the graph, right? So how do we get the first number directly from the graph?
From the center, count to the first.
Yeah, from the center, how far to that vertex, right? Remember, A and B is how far from the center to the edge. So how far is it from 7, 5 to 7, 7? 2 squared. That goes under y because that's up, down. So we can always get the first one right off the graph. Is that making sense? And then the other one we call B, and now we write the focus equation, huh? Same thing as always. See this game we're always playing?
We know C.
Yep. So let's come over here, write the focus equation, the Pythagorean.
C.
It's got a plus, right? Minus in the main, plus in the focus. A squared is 2 squared, B squared. And what is C?
3 squared.
3.
Yeah, because
Singular C is 3.
from the center to the focus, C is 3. From 7, 5 to 7, 8.
3 squared.
C is 3.
9 minus 4 is 5.
We good? 4 plus b squared is 9. 4 plus b squared is 9. So subtract that 4. B squared is 5. Rooted. B is the root of 5. We are done. So root of 5 squared, done.
Would I let us type it like that?
They probably just want you to say 5.
Okay.
Yeah. Oh yeah, they probably just want you to say 5 there. That would be my guess. Everybody see what we did there? So that was a little trick. The trick on that one was finding the center. The new part of that one was finding the center. Which is averaging, isn't it? Good? Can I move on? We okay with all that? Okay, and they want the equation. Yeah, the equation. Okay, this is going to be super easy. It's going to be just like the box one in the way that they're handing you everything. There's hardly any work to do. Here's what I mean. When they give, remember when they gave me the box, that was basically everything? Well, when they give you the asymptote equation, same deal. That's basically everything. Everything is in that asymptote equation. Everything but one small thing, which I'll show you in a minute. I'm going to ignore the vertices for now. I do need them, it turns out, for a super small thing. But let me just pretend they're not even there for now. Just say, hey, look, they're giving me the asymptote equation. So I'm going to just go here and go, all right, I'm going to put the x, and it's going to be x minus 1. What they put is exactly what goes there. Y plus 2.
So when it's in this form, we know that x comes first?
That's the only thing we don't know.
Oh.
It is, and I'll show you why. But let me save that for now. So does that make sense? I'm just going to put the x minus 1, put the y plus 2. And then what goes underneath x? What goes underneath this?
4, 3.
Yeah, remember the slope is rise over run, huh? This is rise, this is run. So what goes under x has to be the run. 3 squared there, 4 squared there, right?
Hear what I mean, not what I say.
And mine's here.
And we're done. Now, the only question is Renee's good question. How did I know x came first? And that's because I knew about the vertices. So that's the only thing you need the vertices for, is to know whether x comes first or y comes first. So let's do the vertices real quick. Back 5, 3, 4, 5, down 2. The other one's 1, 2, 3, 4, 5, 6, 7, down 2. See, they're side by side. So the branches have to go sideways, so x has to come first. Done. That's all I needed the vertices for.
Well, also, like, you know,
Oh.
yeah.
Okay.
No, I
Y is plus 2 and it's negative 2 on there, so you kind of know that that's not going to change. X is the one that changes, so X is going to be.
what's that? No, I can't know from the asymptote equation.
No, the vertices.
Oh, right, yeah. So from the vertices, yeah, right. Yeah, so does that make sense then? So really the asymptote equation gives us everything except which one comes first. The vertices are side by side, so x comes first, and then we just put everything in there. You see, the deal is this x minus 1 and this y plus 2 in the equation, that's a shifting of the graph. It's the same way that the center of the asymptote lines, the x, the center of the x is shifted. Same as the whole graph. So they're the same. So that's just like giving you the box. It's just handing you everything. Right? Good? You know, so how would you know right away that you have to do that whole completely square thing on this?
It's a mess.
It's a mess.
Yeah, it's a mess. And there's no parentheses squared, huh? Abdul? So no parentheses squared. So
The first thing that we're gonna do,
complete.
subtracted 1 from the set.
Good, exactly. Yeah, so remember how the steps go. Step 1 is kind of an organized step, isn't it? Where you get the y squared next to the y, and the x squared next to the x, and the numbers to, the number, the negative, the positive 1 there, yeah, the number to the other side. Yeah, so grab that plus 1 and just jump it to the other side. In other words, just subtract 1 from both sides, huh? So it's just organization. So step 1 is just organization. So y squared minus 8y, leave a blank. Minus x squared minus 2x, leave a blank. And now the minus 1 is gone to the other side. Are we good so far? So the first step, just like for the ellipse 2 days ago, same thing when you complete the square. First step is organization. Just get the y stuff together, the x stuff together. Get the numbers out of the way. Why did I move that number out of the way? Because he's not the number I need. I need to find, I'm going to leave blanks to find the completing numbers that are just what I need, and it's not the minus 1.
Can you factor out a minus 1 from the x terms like right away?
In fact, we must.
Okay.
That's the new wrinkle. Step 2. Remember what step 2 was for the ellipse? It is factor out any number in the front of x squared or y squared. Yeah, any number, if you can read my pins breaking up there. So factor out any number in front of x squared or y squared. So, okay, so we don't have any number in front of y squared, so nothing to do there. Yeah, but in front of the x squared, we have a negative 1, don't we? So that must be factored out. And you got to remember from your algebra days, what happens when you factor a negative out of the front of stuff? All the signs are going to change. Yeah, because negative 1 times what would go back to negative 1x squared, well, just x squared. And then negative 1 times what would go back to negative 2x. Negative times what is negative? Positive 2x. So see how it changes all the signs? Right? It was negative x squared, now it's regular. It was negative 2x, now it's positive. Okay, so now that's the same. We had to do that for ellipses as well. We just didn't have a negative. We had to factor out whatever number was in the front. All right, step 3 is find the completing numbers. Right? Which is the number next to x or y, yeah, same thing, over 2 quantity squared. Remember that? Number over 2 quantity squared added to both sides. Remember that? So we got to find those completing numbers.
But you're going to subtract 1 from...
So how do we find those completing numbers? So here it is. Take that negative 8. I'm going to go over here. Take the negative 8, put it over 2, square it. That's negative 4 squared. Positive 16. They're always positive, aren't they? Those completing numbers are always positive because they're squared. So positive 16. So you got to put a positive 16 right there. But if I add a brand new positive 16 on the left side that wasn't there before,
You have to do it to the right side.
I got to do it to the right side because you got to keep the balance here, huh? We can't change the problem. So I got to do a plus 16 over there. Okay? Now be careful with the x one. You ready? So we take the number next to x.
Put it over 2.
Are we all good? Y'all caught up with me? You're watching this? This will be important. Take that number next to x.
2 is 1.
Whoop, I'm making the whole thing jump around here.
But you're going to subtract 1.
Bring this over. Put it over 2. Squared 1 squared plus 1. So I go plus 1 and what?
Add negative 1.
Yeah. Yeah, exactly. You guys are getting it. Good. Good. Yeah, you got to realize, what did that actually do to the left side? Because what it actually did to the left side, you must actually do to the right side. You got to keep the balance. So by putting a plus 1 there under the influence, that's the drunken driver there. That one's under the influence of a negative 1, isn't he? He's not free and on his own. He's under the influence of a negative 1. In other words, if you multiplied out that left side, there would be a brand new negative 1 there. Not positive 1, huh? So you got to really do the right side by -1 also. Does that make sense? Just like we did some of that with the ellipse, huh? You got to realize anything you stick into a parenthesis, he's under the influence of that number in the front. That's what he really is. And you got to do that to the right side. Does that make sense? If I multiplied out these guys, do you see that I would get -x squared minus 2x? They were already there. They're way back here. They're nothing new. But there'd be a brand new -1. By putting that +1 under the influence of a -1, I really affected the left side by -1. Same thing on the right. All right. So now what becomes of this? Well, what becomes of it is these three are guaranteed to factor. It's the completing number. It completes it so that it factors as the same thing twice. What? -4, -4. Because remember, they add to be the middle. They multiply to be the +16, right? -4 add to be -8. They multiply to be +16. -1. And then what are these guys? These guys also guaranteed to factor. They add to be 2. Multiply to be 1, +1, +1. Equals, and what happens over here? -1 and...
14.
Wait, what just happened? Something's wrong.
You get 14.
Did I copy the problem down wrong? It was -1 from the beginning. Whoops. So, I messed up. It's not a big deal. -1 here. This should be +1 on the other side. Plus, see, I knew there was, see, I was canceling them because I've done this problem so many times. I know they're supposed to cancel. So,
16.
there we go.
No, wait, what?
16.
Yeah.
That good? All right, so then this gives me y -4 squared. You don't need the 1 anymore. The -1 doesn't do anything. 16. We good there? Much nicer now. Much nicer numbers now. Can I go to a fresh screen? There's only one more step. What do you got to do? Divide through by 16. Yeah, I'm just going to move on if you're okay. Well, there's a whole bunch more, but I don't want to do it. Now they want you to graph it, find the vertices, the asymptote lines, the focus points, blah, 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 blah.
If the sign is going to be, for this one, it's going to be -x squared minus 2x. So if it's going to be x squared minus 2x, so the middle sign is going to be positive, it's going to be ellipse. So what are you going to do?
It's not going to
I know that's not ellipse, the y squared minus 8, if this one is going to be like positive x squared, not negative squared.
Oh, if this guy was positive, you're saying?
So the middle,
It'd be an ellipse.
yeah, ellipse.
So it'd be an oval.
That's it.
Yeah, you just make it over. Yeah, we did some of those. Those would be some of the ones we
I know
did.
that's why I said probably that.
That's right, yeah. So if they're both plus, then it would be an
This
ellipse.
would actually
Yep.
be a circle since it's nominated.
Yeah,
16,
right. All right. Okay, there you go. So start off. Let's do the quiz. He's going to have a cut. This is the hardest one. Honestly, I'm not going to give you one this hard on the exam. It's going to have some extra tricks, but if we do this one, we can do anything. So this will prepare you. This has 2 special tricks. So first off, organize. Get the X stuff together, get the Y stuff together. Push that plus 36 to the other side. Make it minus 36. Get it out of the way. It's not our completing number, so just get it out of the way.
Divide by him by 2 is 5. Factors by 100. So plus 100.
All right. I'm going to be going. Let's go fast if we can so we can get through this thing. So here we go. So let's organize. 4x squared, 24x. Just keep those guys together. Leave a blank. Minus y squared plus 10y. Grab that 36 and jump him to the other side. Minus 36. So step 1, organize. Okay. What's step 2? What are we going to do now? Factor out, right? So any number in front of x squared or in front of y squared, factor it out.
I got that for you. Okay, so
So factor out the 4 here.
plus 30 squared.
And for the y squared, factor out the negative 1, huh? We doing well?
Equals negative 25. By negative 25.
Now, we've got to find the completing numbers. So I'm going to grab this 6, take it over here, put it over 2 squared, which is 3 squared, plus 9. The completing numbers are always positive, aren't they? Because they're squared.
You can't divide by negative.
Plus 9.
Maybe it's a 9.
Yeah, that's what you need to do. Divide by the negative 25 all the way
It
through.
turns into a 9.
No, both signs will switch.
Oh.
So the things will switch positions. Who's in the front, who's in the back.
I was supposed to say the
Oh.
whole thing. was-
Okay.
Good on that. And then grab the minus 10
Because this is actually,
over 2 squared.
Well, at least the negatives cancel out here. So it becomes plus.
no, it can't become plus because that would make it an ellipse. Or no,
You're dividing by a negative. That's
this would be the negative, so it would be this minus.
Positive 25. Are we good to there? Am I racing ahead of you? You okay? So now, these guys are going to... I forgot to do the right side, huh? So whatever I just did to the left side, I've got to do to the right side. So I just put in a brand new 9, but he's under the influence of a 4. So that really added 36. Got to also add 36 to the right side. And I just put in a plus 25, but he's under the influence of a negative 1. So I really just subtracted 25. Good there? All right. Let's see what we got. So this will be 4. This will factor x plus 3 squared. Okay, if I just write it that way. And this is going to be y
I don't think you can.
minus 5 squared. What's going to happen over here?
Here's negative 25 too.
Negative 25. We good so far?
I'm stuck.
Is that okay so far? Everybody with me? Because now come the 2 curveballs.
This switches.
Yeah.
We're at bat,
Positive, this is
and the
negative.
pitcher's throwing the junk stuff.
So it's still
Here it comes.
hyperbola.
So first one is, what do we got to do to? It's all about giving it the right look, huh? So keep in mind what that look is. Let me go over here and write. What's the general look? You want like x minus a number squared over a number, squared, minus, y minus a number plus or whatever, squared over a number squared equals 1, right? That's the look we're going for, right?
No, it's
For our convenience. We make it look that way for our convenience. Okay, so what do I do next? I got to get a, 1 on the right side?
So it's only negative.
So divide through by negative 25. Okay. Because that'll make that 1. Now, whatever you do to one part, you got to do to all. So divide through by negative 25. Now, this is the first curveball. What happens with the signs?
It becomes.
Okay, so you guys know a negative that's on a fraction doesn't matter where it's at. Bottom, top, front, whatever, it's all the same. So I'm going to grab this minus and just say, hey, just pull him to the front. So that's minus 4 times x plus 3 squared over 25. Minus and minus, this one comes out there, hits that one, plus y minus 1 squared over, I don't need that 1 anymore up there. And this 1. Good so far? It changed their signs, which is what dividing by negative always does. Changes everybody's signs. In other words, they should now swap positions.
Yep.
Do you see what happened? The y guy needs to go in the front because he's the positive one. Now, you don't have to. If you want to just leave it, this is all just for our convenience. All of it is. If you were a computer and your mind could just go brrr and plug in a million numbers, you could just do the first step. You wouldn't need to do any of this. That's what computers do, right? But we're not computers. We need help. We need to make things organized in a certain fashion so it's easier for us to graph and find, find everything, the focus points and asymptote lines. So it'd probably be easier for you to put the y in the front. So I'm going to put the y in the front, put that guy in the back. Whatever sign's in front goes with them wherever they go, right? When you move things around, whatever sign's in the front, that's their baby, goes with them wherever they go. So let's reorganize it. So, whoops, we got stuff there. So what do we have? Y, what was it? Minus 5 squared over 25 minus 4x plus 3 squared. 4x plus 3 squared over 25 equals 1. Is that 4? I got it all right? Okay. So there was the first curveball. That was the minor junk pitch. Here comes the major junk pitch. Yeah, what about that 4? Renee's question is the question of the hour. We're not supposed to have a 4 there. You know what I mean? Well, what's the look? Do you all see that? Do you see the problem for stuff? Right? Here's the look. You're supposed to have a number on the bottom only. You're not supposed to have a number right there. Bottom only, not right there. Can we just ignore it? No, it's
divided by 25, 6.25.
So somehow we have to do some fancy plastic surgery. We have to make that thing look different so that there's only numbers on the bottom. We don't want a number up here without changing the value. So how do we do that? We got to get rid of that 4. We don't want a number in the top.
25 fourths.
By a weird one.
Yeah, do what, Renee? What'd you say?
25 fourths.
Exactly. Just divide top and bottom by 4. Bye-bye. That's same thing top and bottom, so I'm not changing anything, right? Is that good? Can you handle that junk pitch now? So if there's something in, honestly, I'm not going to give you that on the test. So you just divide top and bottom by 4. It gets rid of that number on the top. We haven't changed any value.
Right.
So now this is gone, so that's okay. I'll just erase this. And it's just 25. Now it's just a number on the bottom. Now that's a little weird looking. Let's make them squares. That's the one other thing. This is 5 squared, right? And 25 fourths, what squared is that?
5 halves.
5 over 2 squared, huh? And you can use it that way, or 5 over 2 is 2.5. That might be a little easier to have a decimal. There we go. We made it through both the junk pitches. Now let's do this. Let's finish up the problem with our last 6 minutes. Let's graph it, find the asymptote lines, focus points, the vertices, everything they always want us to find. Let's go all the way on this one. All right, let's start with the center. What's it? In fact, let me just go to the graph here. How about that? I'm just going to go right to the graph. Center is, okay. Yeah, the center is opposite. Oh, this one always tricks me. All right. Center is, make a graph like this. Okay. The center is opposite. So it's opposite of what's next to x. That's back 3. And opposite of what's next to y, up 5, huh? I get my x's and y's through. I always want to just grab whatever's in the front and go sideways. That's not right. So back 3, up 5. Opposite. That's the center, isn't it? Opposite. Okay, now let's make the box. Let's make the dotted box. So whatever's underneath y is up, down. So I'm going to go up 5. 1, 2, 3, 4, 5. There's the top of the box. 1, 2, 3, 4, 5. There's the bottom of the box. Whatever's underneath x, right, left. Now, how do you do 2.5? Test will be multiple choice. Just do the best you can. Just eyeball it. 1, 2, and a little half. 1, 2, and a little half. Make a dotted box.
Aren't those also the vertexes?
Uh-huh.
Okay.
Everybody okay there? Kind of getting messy. So does that make sense what I did? From the center, I went up 5 and down 5, because that's what was underneath y. Y is up, down. And I went right 2.5, left 2.5, because that's what's underneath x. Make the box, fill in the diagonals. Let the diagonals shoot out the corners. Like that? Okay. So where do the branches sit? Are they right, left, or up, down? Yeah, because Y's in the front. The branches are up, down, aren't they? So I'm not going to put the one up top. It's just going to get too messy. So we're starting from the middle of the box and heading towards the asymptote lines, right? It'll go like this and head over like that, right? Yeah, I guess that's better. Here we go. Okay. Good to there? Now let's answer all their little questions. They're going to ask us for, first off, the center.
-3.
Yeah, the center is -3, 5. And then they're going to say, find for me the vertices.
-3, 10.
So actually, they're going to do them one at a time. They're going to say, find the lower vertex and the upper vertex. All right, so that's right here and right there, isn't it? Vertex is always the center of the branch. The center of the branch. So yeah, so what's the coordinates of those points? The easy way, I mean, you can look at the graph and that's probably good, but I think it's easier just to take the center, take the -3, 5, and remember I went up 5 and down 5 from the center? So you go up 5, that'll be 10, that'll be the upper one, -3, 10. And then you go down 5, that'll be the lower one, -3, 0. That good? This is -3, 0. This point here is -3, 10. Those are the vertices. Now they want the focus points. Let's find those. They'll want the lower focus and the upper focus. Where are the focus points? Always inside the branches, huh? So maybe like there and like there, roughly, right? How do you find them? Focus equation. Running out of time and space here, so yeah, let me just go over here. So for the focus equation, a squared plus b squared is c squared. Maybe I have room up here. Okay, what's the a and the b? Oh no, I don't have room. The a and the b are the numbers that were under x and y. I've kind of erased them. It's 5 and 5. This time they make you use the fraction. So 5 squared and 5 halves. So 5 squared and 5 halves squared is c squared. So that's 25 plus 25 fourths. They make me do fractions here.
The square of 25.
So you guys with me? This is our last minute here.
5 root 5 over 2.
How are we going to solve for c there? We got to add them together with a common denominator. Put this over 1, top and bottom by 4, right? To add fractions, common denominator. 100 over 4 plus 25 over 4. That's 125 over 4. Root it. Root it. So c is the square root of 125 over the square root of 4. Now 125 is 5 quarters. 5 quarters makes $1.25, right? So that's going to be, and the root of 25 is 5. So that's 5 root 5 over 2. Root of 4 is 2.
And then -5 root
Plus or minus, yeah. So c is plus or minus 5 root 5 over 2. You good there? I'm going to go back. So that means the lower focus, take the center, and you're going to add and subtract. So we're going to take -3, 5 minus 5 root 5 over 2, and -3, 5 plus 5 root 5 over 2. You see that? It's 5 plus or minus the c, right? Because you go up c and down c to get from the center up and down to the focus points. So you got to add and subtract the 5 root 5 over 2 from the center. Last thing,
The equation of the lines.
the equation of the asymptote lines. With our last seconds, let's do that. So the asymptotes, how do you do it? You just use exactly what's in the equation. Y, was that minus 5 or minus 5, huh?
Yeah.
Y minus 5 is plus or minus, and you're going to put here x plus 3.
Is it 1 minus 5?
Rise over, not squared.
Okay.
No, it's y equals mx plus b, right? Regular y. Rise over run. What's the rise? 5. It's whatever's under y. What's the run? 2.5. What's 5 divided by 2.5? How many times does $2.50 go into $5?
Twice.
Twice. That's 2. So I'm just like totally out of room and out of time. Y minus 5 is plus or minus 2 x plus 3. Do you see that? That becomes 2. 5 divided by 2.5 is 2.
So 1 minus 5 goes plus or minus 2.
There we go. That's the worst. I won't give you one that bad. I promise. On the exam.